everyone! Welcome to the new episode of Fun and Exciting Learning. I am Giancarlo T. Rivera. Together, we will learn mathematics and conquer problems dealing with it. For this video, we will discuss most essential learning competency number 1 for Mathematics 10, which is generating patterns. Before we formally proceed to our lesson, let us have a quick game. I am sure you are familiar with 4 picks 1 word. The mechanics of this game for this video lesson is to guess the word that is depicted by set of pictures. You will be given 30 seconds to answer. Are you now ready? Let's now proceed to the first set of pictures. 30 seconds. Start now. Time's up. Let's see whether you guessed the word correctly. Let's now reveal the answer. Did you guess the word correctly? If so, great! Let's now proceed to set number 2. 30 seconds. Start now. Okay, time's up. Let's now check whether your answer is correct. Let's now reveal the answer. The answer is sequence. Did you guess the word correctly? If so, you did an awesome job. That game gave you an idea what will be our lesson for this video. For this video, we are going to discuss patterns and sequences. Unconsciously, we are always engaged with the concept of patterns and sequences. Example, our daily routine. Another one is the way we set our goals, experience struggles achieving those goals, and setting a new goal, and activities that repeat, resemble pattern. For this video, we will try to make sense of the importance of patterns and sequences in real life. And to start this video presentation, let's establish our lesson objectives. First, at the end of this video, you shall be able to define sequence correctly. Secondly, you shall be able to identify the end term of a sequence given its rule. Now we define what is pattern. A pattern can be formally defined as a noticeable regularity in the natural and man-made world that repeats itself in a predictable manner. Examples of natural patterns include waves, lightning pattern, as well as the periodic behavior of visit of a certain comet. Another definition of pattern: it is a series or sequence that repeats. Math patterns are sequences that repeat based on a rule. And a rule is a set of ways to calculate or solve a problem. It can be considered as a mathematical relation that is used to model behavior or mathematical phenomenon. Where do we apply patterns? Do you play puzzle games? Just like Rubik's Cube? Or Tower of Hanoi?
Whenever you're ready.
There you go. In playing such examples of game puzzles, we follow certain pattern for it to be solved. In this case, patterns provide a sense of order. It helps us develop important skills of critical thinking and logic.
Whenever you're ready.
Patterns can also be applied in arts and architecture. In architecture and arts and design, patterns can be used to create visual effects on the observer. And of course, patterns are applied in music. All of us love music, especially music which not just touch our hearts, but also our soul. Music is made up of patterns. We sing songs in which words and melodies are repeated, just like this.
There was a farmer had a dog. Bingo was his name. B-I-N-G-O, 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 and Bingo was his name.
I got my ticket for the long way round. You got a whiskey for the way. And a show good like country company. And I'm leaving for the wedding day. And I'm gone. You're gonna miss me when I'm gone. You're gonna miss me by my head. You're gonna miss me everywhere. Oh, you're gonna miss me when I'm gone. I'm gone. I'm gone. You're gonna miss me when I'm gone. You're gonna miss me by my home. You're gonna miss me by my Toto. You're gonna miss me when I'm gone.
Sing along with the repetitive lyrics of the nursery rhyme Bingo. B-I-N-G-O, B-I-N-G-O. Or with the song of Cops. That is a song by American singer Anna Kendrick from the soundtrack Pitch Perfect. The song is a version of When I'm Gone, a 1931 song by the Carter family. The original version was usually performed a cappella with a cup used to provide percussion, as in the cup game. Let's now continue our lesson by defining sequence. Earlier, we defined math patterns as sequences that repeat based on a rule. What then is a sequence? Sequence is defined as a string of objects, like numbers, that follow a particular pattern. Secondly, it is defined as it is a function whose domain is the finite set 1, 2, 3 until n, or the infinite set 1, 2, 3, and so on. So based on this definition, we can conclude that sequence can be finite or infinite. So when we say finite, the number of terms in a sequence is countable. On the other hand, when we say infinite sequence, the number of terms cannot be identified, since it is an endless progression of discrete numbers. Let's consider this sequence for example. The terms of the sequence are 2, 4, 6, 8, 10, 12. So what do you think of this sequence? Is this finite or infinite sequence? Yes, this is finite sequence because we were able to count the number of terms in this sequence. We found out after counting we have 6 terms in the sequence. Furthermore, sequence can be described in 2 ways. First, by describing it in words. For example, this sequence can be described as a finite terms of multiples of 2. On the other hand, we can describe it mathematically by describing it in a rule, or a mathematical expression which describes and generates the sequence. This can be described as f of n is equal to 2 times n such that n is greater than or equal to 1 but less than or equal to 6. This expression of inequality suggests we are going to use the domain 1 to 6, including 1 and 6. So when we substitute, 2 times 1 is equal to 2, which means 2 is the first term. We use now 2 as n. 2 times 2 is equal to 4, which suggests 4 is the second term. We now use 3 until 6. So, arriving at the sequence 6, 8, 10, and 12. Let's proceed to example number 2. We consider the sequence 4, 8, 12, 16, 20, and so on. So, what do you think of this sequence? Is this finite or infinite sequence? Obviously, it is an infinite sequence because of these ellipses. Let's now describe this sequence through words. This can be described as an infinite terms of multiples of 4. Mathematically, it can be described as f of n is equal to 4 times n, such that n is greater than or equal to 1. That means any number that's greater than 1 can be input in this function. So, if you wish to verify that this sequence or this rule generates the elements or the terms of this sequence, we can do that. So, we will just insert values, which is n is greater than or equal to 1, into the function f of n is equal to 4n. So, that will be 4 times 1 is equal to 4. So, that's the first term. When you wish to verify that the second term is 8, so we will insert n is equal to 2. 4 times 2 is equal to 8. When you wish to verify that 12 is the third term, so you will input n is equal to 3. So 4 times 3 is equal to 12, and so on. As you notice, there is a unique correspondence between the value of n to the value of f of n. Because, as we defined, sequence is a function, and a function is a relation which associates input values to unique output values. So this is an illustration of function. Whenever that we input value of the mean into the function, there will be an expected output value of the function itself, and that is 1 to 1. Therefore, the relation between input and output is unique. Let's now evaluate some terms of a sequence, given its rule or function. Write the first 5 terms of the sequence generated by the function f of n is equal to 3n plus 2. So, since the first 5 terms are being asked, we will let n as the domain 1, 2, 3, 4, 5. Of course, since our domain is countable, the sequence we are going to generate is finite sequence. So, we will just input this set of values of n into the function f of n. So, when we input 1 as n, so we will evaluate that as 3 times 1, which is 3, plus 2, which is 5. So the first term is 5. So we evaluate now the function when n is 2. So that will become 3 times 2 is 6, plus 2 is 8. We evaluate n as 3, that will be equal to 3 times 3 is equal to 9 plus 2 is 11, and so on. Therefore, the first 5 terms generated by the rule or the sequence f of n is equal to 3n plus 2 or 5, 8, 11, 14, and 17. But what if you are just interested with a particular term? For example, 10 term, having the same function or rule of f of n is equal to 3n plus 2, what would be the 10th term? So following the same process as what we have done on the previous slide, so you will just input 10 into the value of n. So that will become f of 10 is equal to 3 times 10 plus 2. Then, evaluate 3 times 10, that is 30, plus 2, that is 32. Therefore, the 10th term of the sequence is 32. Do you have questions so far? Let's try some exercises. You will evaluate the first 5 terms of the sequence given the rule below. F of n is equal to 10n plus 3. 1 minute starts now.
T minus 1 minute. T minus 50 seconds. T minus 40 seconds. T minus 30 seconds. T minus 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Okay, time's up. Let's now check your answer.
T minus
Since you're just asked for the first 5 terms, the values of n will be 1, 2, 3, 4, 5. And these values will be inserted into the function 10n plus 3. So, when n is 1, what would be f of n? So that will become 10 times 1 plus 3, that is 13. How about when n is 2? 10 times 2 plus 3 will be equal to 23. When n is 3, 10 times 3 is 30 plus 3 is 33. When n is 4, 10 times 4 is 40 plus 3, that is 43. And lastly, when n is 5, 10 times 5 plus 3, that is 53. Did you get the first 5 terms correctly? If so, let's proceed to another function. Evaluate the first 5 terms of the sequence given the rule f of n is equal to n squared plus 5. 1 minute starts now.
T minus 1 minute. T minus 50 seconds. T minus 40 seconds. T minus 30 seconds. T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Okay, let's check.
T minus 1.
We have now the function f of n is equal to n squared plus 5. So the same input values 1, 2, 3, 4, 5. When n is equal to 1, what would be the value of f of n? So 1 squared is equal to 1 plus 5 is equal to 6. How about when n is 2? 2 squared, that is 4 plus 5 is equal to 9. When n is 3, 3 squared is equal to 9 plus 5, that is 14. When n is 4, 4 squared is equal to 16 plus 5 is equal to 21. And lastly, when n is 5, so that will become 5 squared, that's 25, plus 5, that is equal to 30. Did you get all the terms correctly? Great! Let's now proceed to another function. F of n is equal to n plus 5 all over 2. 1 minute starts now.
T minus 1 minute. T minus 50 seconds. T minus 40 seconds. T minus 30 seconds. T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Okay, time is up. Let's check whether your answers are correct.
T
So we have the same input values or domain 1, 2, 3, 4, 5. So we will input these values into the function f of n. So let's start. When n is 1, what is f of n? So 1 plus 5 is equal to 6. Divided by 2, the answer is 3. When n is 2, what is f of n? So that will become 2 plus 5 is equal to 7 divided by 2, that is 7 halves or 3.5. When n is 3, 3 plus 5 is equal to 8 divided by 2, that is 4. When n is 4, 4 plus 5 is equal to 9 divided by 2, that is 9 halves or 4.5. And lastly, when n is 5, 5 plus 5 is equal to 10 divided by 2, the answer is 5. I hope you got the terms correctly. Because we believe practice makes perfect, let's have more exercises. Within 3 minutes, you are going to evaluate the n term of each sequence given its rule. The specified term is given beside each function. Are you now ready? 3 minutes start now. Let's check whether your solutions and answers are correct. Let's have number 1. F of n is equal to 5n minus 6, and you are asked to solve for the third term. Therefore, we will use the value of 3 as n. We will input 3 into the function f of n is equal to 5n minus 6. That will become f of 3 is equal to 5 times 3 minus 6. 5 times 3 is 15 minus 6 is equal to 9. Therefore, the third term of this sequence generated by the function is 9. Let's proceed to number 2. The given function is f of n is equal to 7n plus 13, and you are asked to solve for the sixth term. So we will use 6 as the value of n. That will become f of 6 is equal to 7 times 6 plus 13. What's the product of 7 and 6? That will be 42 plus 13, that is 55. Therefore, the sixth term generated by the function or the sequence 7n plus 13 is equal to 55. Let's have number 3. The given rule of the sequence is f of n is equal to 3n squared, wherein you will solve for the 10th term. Here, what would be the value of n? That's correct. The input value will be 10. So we will insert 10 into the function f of n is equal to 3n squared. But remember, in evaluating this, you must remember the correct order of simplifying mathematical expressions. So in this case, we need to evaluate first the exponent. So that will become 10 squared will be equal to 100, and evaluate the product of 3 and 100. And that is 300. Therefore, the 10th term of this sequence generated by the rule 3n squared is equal to 300. Let's continue answering number 4. The given rule of the sequence is f of n is equal to 5n cubed minus 3, and you are asked to solve for the third term. Bear in mind that you should evaluate this following the correct order of operations. Here, the input value will be equal to 3, or n is equal to 3. Therefore, the expression or the equation will become f of 3 is equal to 5 times 3 cubed minus 3. In this case, we will simplify first this 3 cubed. So, what is 3 cubed? That is the same as 3 times 3 times 3. And that is 27. Then, what will be performed next? That is the product of 5 and 27. Evaluate that. That is 135. Then you can now subtract 3 from 135. And that is 132. Did you get the correct answer? If so, you are doing a good job. Let's now proceed to last number. Number 5. The given is f of n is equal to n squared plus 3 all over 2. You are asked to solve for the fifth term. So what would be the value of n, or the input value? That's correct. the input value should be 5. So therefore, simplifying the equation, that will become f of 5 is equal to 5 squared plus 3 all over 2. In this case, we must simplify first what is the numerator. That is 5 squared plus 3. You must solve for the value of this first. So 5 squared is equal to 25 plus 3 is equal to 28. That is to be divided by 2. That's 28 divided by 2 is equal to 14. Therefore, the fifth term of the function or the sequence generated by the rule n squared plus 3 all over 2 is equal to 14. Did you get the correct answer? I hope you got all the answers correctly. If you have questions and comments or insights regarding this video, please don't hesitate to write it down on the comment section below. Now, let's summarize what we have learned from this video. First, we have known that pattern is a series or sequence that repeats. Math patterns are sequences that repeat based on a rule, and a rule is a set of ways to calculate or solve a problem. Secondly, we defined sequence as a function whose domain is the finite set 1, 2, 3 until n, or the infinite set 1, 2, 3, and so on. And lastly, we have evaluated the n term of a sequence given a rule by letting the desired n term be the input value of the given function or a rule. For the extension of your learning experiences from this video, I am giving you homework. First, comment your thoughts in comment section. Why is that understanding patterns and sequences important in real life? Secondly, study arithmetic sequence. And that ends our learning session. Again, I am Sir JC, reminding you, math is easy when you perceive it positively.